And good morning to those of you on the West Coast, afternoon to folks on the East Coast in the US, and good evening in Europe. Thanks for joining us on our next Dolby Atmos webinar. This one is our Dolby Atmos Content Creation Deep Dive, and it features Adam Pinch, who you see in the second video window there. He's our Senior Staff Solutions Engineer based in our San Francisco headquarters office. And on the line, we also have Mark Chesler, who's our Content Tools Partner Account Manager, and he is in New York City. So he and I are going to be fielding questions, and Adam is actually going to be doing most of the talking here. First, a little bit of housekeeping, just about upcoming events and places to watch previous events. In the news, just this week, you may have seen that at the Apple Worldwide Developers Conference, they announced that AirPod Pros are going to have Dolby Atmos playback support. So we're really excited about that when that feature goes live. The AirPod Pros will be able to play Dolby Atmos, as well as they will have a head tracking feature using the internal accelerometers, so that when you turn your head, if you turn the feature on and you're watching something in Dolby Atmos and say the person on the sofa next to you starts talking, you turn your head, but the sound field stays in the front. So that's a really neat feature in addition to the overall Atmos capability. In addition to music theater fans, you may have seen the announcement that Hamilton is going to be coming to Disney Plus on July 3rd, and now it is public knowledge that it is going to have a Dolby Atmos mix as well as a Dolby Vision color grade. And the folks who have already heard it say it's literally like you're sitting fifth row center at the Richard Rodgers Theater. So we're really, really excited about that going live in about a week and a half. And we're actually hoping to speak to the re-recording mixers of that show about how you would remix a stage musical into Dolby Atmos for home. So I'm hoping that's going to be an upcoming webinar in our series. Another upcoming webinar we're planning is, and my stupid title for it at the moment is, why is that in Atmos? What Dolby Atmos brings to the party for non-traditional shows, like, for example, Chef's Table, a foodie documentary on Netflix, and just the power of Dolby Atmos for things that are beyond, pew-pew sci-fi type shows. So we're lining up some mixers and some shows to talk about along those lines, and that's going to be an upcoming webinar as well. And we always seem to run out of time on these things, so let us know what you think in the questions. We're thinking also about doing an all Q&A webinar, just about everything we've already covered in our previous webinars. So let me bring up my PowerPoint right now. I want to show you a couple of items. As we mentioned in previous webinars, our Dolby Atmos Production Suite offers a free 30-day demo trial. So if you shoot that QR code, it'll take you to our registration site where you can register and then download Dolby Atmos Production Suite. Avid is also promoting currently a 3-month demo of Pro Tools Ultimate. So between Pro Tools, Dolby Atmos Production Suite, you suddenly have yourself a Dolby Atmos mixing system. If you saw our previous webinar about Sol Levante, the original 4-minute anime, the first hand-drawn anime in Dolby Vision, Netflix released the mix assets of Sol Levante for anyone to download and play with. That's what that second QR code is. Our webinar series isn't currently on the same primary site as the rest of them because we're currently rebuilding those websites. But our Dolby Atmos webinar series is located at that third QR code, so you can catch up on the ones you may have missed. And then finally, professional.dolby.com, the fourth QR code there, that has other webinars, including our Dolby Atmos Music series. It's all about mixing Atmos for music, our Dolby Vision series, and also podcasts from the Dolby Institute. So all that stuff is available for you to watch later. And this webinar will be up on our site as well in the future. So, okay, I've done enough talking. Let me switch over to Adam, and I'll give him control of the presentation. And clickety-do, there we go. And so, Adam, welcome. Thanks for being here with us and getting your presentation ready for the masses. And please take it away.
All right there. So good morning, good afternoon, Webosphere peoples. My name's Adam Pinch. I'm in San Francisco. I have no QR code, but that's probably okay. Today we wanted to build on some of the previous presentations that have already happened and do a little bit more of a deeper dive and a little bit of a look under the hood of how Atmos works, what the tools are, and the workflow. So let's see if we can't get things moving along here. So what we want to do is discuss these topics basically. And this will give you a better idea of how Atmos works in general, and also I want to touch on some of the support resources that are available to you. So just to make sure everyone's seeing this, we're all good. Tom, I'm assuming you'd let me know otherwise.
Yep.
Alrighty. Okay, well, without further ado, let's dive into some basic Atmos concepts, and this may be a tiny bit of a rehash, but then it should go into some new content. So with multi-channel audio, the multi-channel audio we all know and love, 5.1 or 7.1 channels correspond to specific speaker locations. You want something to come out of the left surround speaker, you bus or pan it to the left surround speaker. You want it to come between the left surround speaker and the left speaker. You pan between two channels to create a phantom image. That concept is still alive and well in Dolby Atmos. They're called bed channels, and they go from stereo all the way to 712, meaning 7 floor speakers, a subwoofer, and 2 overhead speakers. What Dolby Atmos brings to the table, in addition to 712, is audio objects. And audio objects are audio channels that are recorded along with positional metadata. The Dolby Atmos content creation system can handle 128 inputs. The first 10 of those are dedicated to the bed channels that function like normal multi-channel audio, with the addition of 2 overhead speakers, but up to 118 audio objects. Now, the first acronym for the day is OAMD. So each object is recorded along with XYZ positional coordinates, as well as size information. These are dynamic, and they're recorded over time. The second main concept of Dolby Atmos is the Object Audio Renderer, or the OAR. This is your second acronym of the day. So to reproduce Dolby Atmos, an OAR is required as an integral part of the technology. The OAR renders objects to the spatial coordinates supplied by the OAMD, along with the audio, to use the available speaker configuration to recreate the positional coordinates as best as possible. So these two acronyms here really are what Dolby Atmos is all about. You have OAMD, object audio metadata, and then in the reproduction and playback environment, you have an object audio renderer that takes that OAMD and recreates recreates the immersive sound field in how it was created. So if you take anything away from today, OAMD and OAR basically are Dolby Atmos. Now, the object audio renderer is a tool that keeps showing up at multiple places along the workflow. It's used in content creation to render to your speakers during content creation. It's used in our encoding process, and it's also used in the decoding process in the consumer's home or in a movie theater to actually reproduce the Atmos in the final listening environment. So OAR is present throughout the delivery chain. So I want to talk a little bit about the differences between cinematic Atmos and home theater Atmos. As I mentioned, the Dolby Atmos content creation tools can handle 128 tracks of input, between beds and up to 118 objects, and all the OAMD for all those objects. So in cinematic Atmos, we can deliver all that content, all that all that PCM, all that metadata, and it plays off of a Dolby Cinema server and hits a Dolby Atmos cinematic processor and uses all the OAR uses all the OAMD to render to the 64 plus speakers that are present in a Dolby Atmos theater. Works great, immersive experience, everyone is happy. Obviously, pushing 128 channels of PCM and metadata to the consumer's home is not feasible. There simply is not anything close to the bandwidth available to do that. So there are some other concepts here that get utilized to present Atmos in the home theater environment. They are spatial coding and delivery codecs. So spatial coding is used to, it's a process that's used to dynamically group nearby objects, nearby audio from bed and objects using loudness and positional algorithms into elements or clusters so that they become their own objects and have their own OAMD. Between 12 and 16 elements clusters, and then again, they become their own objects, are used during the spatial coding process for home theater delivery. This is a way to reduce the overall data set from what could be 128 discrete audio tracks to what's basically 16. And the spatial resolution of 12 to 16 works for home theater delivery. The home theaters aren't that big. There's usually there can be up to 32 speakers, but usually there are less than 16. And the other point is that in Atmos you can have 128 tracks active. In practice, you rarely do. There are not that many things that are usually active at any given time, so that spatial coding, even with very busy content, does a remarkable job of capturing all the audio and with adequate spatial resolution. And I'm just going to quick jump ahead to a graphic that illustrates what spatial coding looks like. So the idea is that all the beds and all the objects, as they are dynamically moving around, these clusters are created, and the clusters themselves dynamically move around, and the objects themselves dynamically move between the clusters, so that you wind up with a reduced data set of 12 to 16 elements from what was potentially up to 128 beds and objects. So the number of elements used with spatial coding is dependent on the delivery mechanism, whether it's going to be streaming content, whether it's going to be for Blu-ray. If it's streaming content, whether it's 12 or 16 clusters is dependent on the data rate of how the codec is used. If it's going to go to Blu-ray, it is user definable, and that's basically due to how much space is available on the disk for how much stuff the disk authors want to cram on there. So spatial coding is a crucial concept for understanding how Dolby Atmos to the home works. Now, in our content creation tools, we have a spatial coding emulation mode. The spatial coding itself happens during the encoding process. But if you're working in creating content for Dolby Atmos home delivery, you need to be able to listen to what spatial coding sounds like, because it is a process that is part of how your content is going to be delivered, no ifs, ands, or buts. So you need to be able to turn on spatial coding emulation so that you can be sure you're satisfied with how your mix is going to sound once it is spatially coded. Now, when you're doing basic initial sound design, there's really no reason to listen to what spatial coding is doing. But as you approach a mix, it is important to turn it on. And the algorithm itself does an amazing job. It is pretty just mind-blowing how well spatial resolution of an Atmos mix of up to 128 objects, 128 channels and 118 objects can be spatially coded down to 16 elements. It is, however, not 100% transparent with all content. So it's important that spatial coding emulation be turned on at the mix stage with our tools. Okay. Moving along. So the fourth main concept, and we've had three so far, right? We've had OAMD, OAR, spatial coding. The fourth main concept for Atmos delivery for the home is Atmos delivery codecs. Codecs are a way to reduce the bandwidth required to transmit multi-channel audio. There are two basic flavors of codecs. Not to go too deep into it, there's lossless codecs and lossy codecs or perceptual codecs. The first codec I'm going to discuss is Dolby True HD. This is a lossless codec for both channel-based and immersive content, and it is used exclusively for authoring Blu-ray discs. So Dolby Atmos on Blu-ray is pretty much synonymous with Dolby True HD. The way that this works is that the spatial coding will take place and render. Spatial coding will take place, get you to 16 clusters. The OAR will then render to 7.1, and the 7.1 is actually what is encoded to True HD, along with all the metadata from the OAMD of the 16 objects or elements we have at that point. So that is what winds up on a Blu-ray. There's a 5.1 presentation that's derived from that, a 2-channel presentation that's derived from that as well. But Dolby True HD is encoded as 7.1, again, spatially coded to 16 to 12, 14, or 16 clusters, most commonly 14 for Blu-ray. Tom can correct me if I'm wrong. Then the OAR renders to 7.1, injects all the metadata, and that is what is encoded as Dolby True HD for Blu-ray. The other codec that's used for streaming delivery is Dolby Digital Plus with joint object coding. Dolby Digital has been around since the 90s. Dolby Digital Plus was a higher efficiency version that built on that basically used, half of the bandwidth required. And then Dolby Digital Plus with joint object coding is how Atmos is transmitted in with streaming services. So in this case, some of the same process holds true. The content is spatially coded to 12 or 16 elements, depending on the data rate that's going to be used. The OAR then either renders it to 7.1 and then down mixes from 7.1 to 5.1, or renders directly down to 5.1, and then there is additional metadata that is injected into the bit stream that is used for reproducing Atmos on the other end, and I'll talk about that in just a bit. One of the reasons that 5.1 is used for Dolby Digital Plus as opposed to when it's encoded as opposed to 7.1 for Dolby True HD is that it means that Dolby Digital Plus with Atmos content is fully backwards compatible with any 5.1 system that can decode Dolby Digital Plus, which is basically every television and AVR out there, as well as several, operating system browsers, etc. So that if somebody receives a Dolby Digital Plus bit stream that has Atmos in it and doesn't have an Atmos decoder, they get the 5.1 experience and all of the audio is there. They're not missing a thing. And I'm going to talk about this a little bit more in just a second. The third delivery codec that we have is Dolby AC4 IMS, or immersive stereo. This is a next generation codec. Dolby AC4 IMS is used to carry Dolby Atmos at very low bit rates. It is, being delivered, developed for mobile uses as well. The IMS component of this, the immersive stereo, uses the binaural metadata created during the Atmos mastering process to create a stream that's compatible with regular stereo devices and to create a virtualized Atmos immersive experience on mobile devices and others, either with headphones or speaker outputs. Okay, so I talked about Dolby Digital Plus and how that worked. I mean, this is a little bit of a little bit of the deep dive here. This shows what a Dolby Digital Plus frame looks like. You'll see that there was this empty space between these audio blocks called skip fields that we now use to make Atmos happen with something called I forget what EMDF, extended metadata format, I believe. Now, the way that this all works is spatial coding takes place, and we wind up taking our presentation that had beds and objects up to 128 total tracks and winding up spatially coding down to 16 elements, or really 15 plus 1, because the LFE gets its own. And that's illustrated on the left side of this as objects 1 to 15 in the LFE. So each of these spatially coded elements or clusters has their own OAMD at this point, right? They go to the OAR, we've talked about this, and the OAR either renders to 7.1 and down mixes to 5.1 or goes directly to 5.1. Simultaneously, these objects are put into what's called the joint object coding encoder. It calculates the difference between what was in the 16 elements it had and what's in the 5.1. The audio itself is encoded as Dolby Digital Plus as 5.1. There's metadata created by the joint object coding encoder that represents this delta between the 5.1 and the 16 clusters, and that is injected into that space between the audio blocks in the previous slide. So we now have a 5.1 bit stream along with this extra metadata that includes JOC metadata and the OEMD metadata from the spatially coded clusters, and all of this travels in the same bit stream. And it is deployed into the bit stream. This winds up packaged as a fragmented MP4 container and delivered by the Netflixes, Disney Pluses, Apple Pluses of the world as either Apple HLS or MPEG-Dash content, streaming to the decoder in the consumer's home, whereupon the Dolby Digital Plus JOC is decoded to 5.1. The JOC metadata is used to recreate the 16 clusters. The OAMD for those 16 clusters is pulled out, and the OAR, our friend the OAR, is used to then render to recreate the Atmos immersive experience in the consumer's home to whatever speaker environment they have, whether it's sound bars, an AVR with discrete speakers, in a TV itself, mobile devices, etc. So that's how Atmos gets through to the consumer's home. Hopefully that explains some of the mystery of getting Atmos from the mix stage all the way to the consumer's home. Now, the renderer itself, our Atmos content creation tools record what's called the Dolby Atmos Master File Set, or DAMF. This creates a couple of different files. A .atmos file, DAMF and .atmos are referred to almost interchangeably. It's an XML file that contains information about the presentation and points to other files in this file set. One is the atmos.metadata file, which contains all of the OAMD from the original objects. And then the audio itself, up to 128 channels, is a core audio file format file. And I'll quick show what these look like, just for the sake of making it clear. You're not really want to, go in and mess with these. In fact, you are actively encouraged not to go in and mess with these, but just so you understand what happens, this is what's actually being recorded when our content creation tools get thrown into record. A .atmos file has information about how many spatial coding emulation it was used. It says where the metadata in the audio is, where the file started, what frame rate it was, if there was a bed, and then how many objects were in this presentation. It's fairly simple. It's a tiny little file. The atmos.metadata file at its core, once you get down into it, this is it. This is the X, Y, Z coordinates per sample, per object. This is really what's actually being recorded along with the audio. It winds up in these two files, and this is what winds up in the Atmos master file format. Now, that's what gets recorded by our Atmos content creation tools. There are other mezzanine formats that can then be exported and that are used for delivery, so that you can deliver a single file rather than a file set. The ADM BWF contains all of the audio, and in a big data chunk at the header of the file creates all the information that I just showed you in the .atmos and the .atmos.metadata file. They are jammed into a data chunk before all the audio. This gives you a single deliverable that can be encoded from, and it also gives you a way to get back into a digital audio workstation so that you can do editing work without having to go back to a DAW session, the original DAW session in the first place. A third mezzanine format is the IAB MXF. This is a way to package media into an IMF package, which is being used but for delivery to Netflix and to others. IMFs, are kind of the holy grail of like one package to create the information to create every possible version of a piece of content for an airplane in different languages, removing different scenes for different countries, all of that information in one package. The fourth delivery, output that our content creation tools generate are what's called re-renders. And these are channel-based deliverables that are derived from the Atmos master. That can be from 916 to 714 for use in, an Atmos gaming engine, to 7151 in stereo for where there's going to be delivery that is not Atmos, so that you can always work in Atmos and still get all the deliverables that you need for non-Atmos delivery. The re-renders can be full mixes or they can be stems if a multi-bed input is used to our renderer, and I'll talk about that in just a second. How are we doing on time here, Tom?
You got about 15 or 20 minutes before we want to start going to Q&As.
All right, I'll get going then. Here's just a quick slide, touting IAB, which is coming into its own as a format. Okay, just really quickly to reiterate, the core functions of our Dolby Atmos renderer are to record the objects in bed along with the OAMD to a master file. And again, this is all slave time code coming from your DAW. Other information that's recorded is the downmix information and trims for how that 5.1 is rendered when Dolby Digital plus Jock is created, along with the binaural metadata that's used for IMS encoding. We can use our renderer to export out to these different formats, to ADM Wave and IAB MXF. It can also encode Dolby Digital plus Jock and package it in an MP4 file for QC, which I'll hopefully get some time to talk about. It does loudness measurement, and the loudness measurement is based off of a 5.1 render that has a limiter stage involved with it that's similar to what our encoder looks like. But again, 5.1 is a 5.1 render is used for loudness measurement because it's going to be eventually packaged in 5.1, and this preserves loudness consistency with other content on a given platform. The Dolby Atmos renderer using the OAR also does the rendering to your speaker configuration in your mix environment, with or without spatial coding, as we discussed. It lets you monitor different down mixes, as well as your primary speaker configuration. It lets you monitor in stereo or listen to the binaural metadata that would be used downstream for AC4 IMS encoding. And it will do real-time or offline exports of these re-renders. And the offline portion of this is pretty handy because it means you're not necessarily tying up a stage to do this. So you've heard me all talk about multiple beds. Now, the idea is again, you have 128 inputs to our renderer available, the first 10 of which are reserved for a bed. But you might want to use multiple beds. So the reason you might want to do this is that, in your DAW, you could have beds for different stems. You could have, the beds and objects for different stems. But if you combine all of the objects into a combined bed that only uses 10 channels of input to the renderer, leaving the other 118 available for objects, that's all fine and good. But if someone says, hey, I'm going to need, a 5.1 dialogue stem of this, or I'm going to need an M&E, then you're going to have to go back to your Pro Tool session or your DAW session, start muting things, and do multiple mastering passes into our renderer, which is how things worked once upon a time, and it is certainly a viable way to work. If you're doing this 4 or 5 times with a 2-hour feature, you could see that this would add up and start becoming rather cumbersome way to work. So with multiple beds, what you do is you dedicate a bed and a group of objects to each stem. And what this lets you do is group these things together in the renderer with an input configuration. And this will let you export custom re-renders for each stem and record all of this information into the renderer in one mastering pass. It also constructively lets you be able to use multiple premix stations, so that if you've got a dialogue premix station, an effects premix station, everyone gets their own bed, their own objects. All of this stuff is recorded into the renderer. You do it in one mastering pass, and then you can also create all the stem-based and full mix deliverables that you want from one render, rather than having to do multiple mastering passes. This is a great idea. The trade-off being that the more beds you have, the less number of available inputs you have for objects. You still have 128 total to work with, but as hopefully I can show you an example. I mean, you could have 6 beds to be able to do all the deliverables you'd ever need to in the world, and you could still have 72 objects, which can, be used quite constructively. The other thing to keep in mind is that the width of any bed can go up to 712, but it doesn't necessarily have to, depending on the content. So again, the whole idea here is that if you use multiple beds, you can streamline the creation of all your deliverables. And what's pictured, and what I can hopefully show you really quickly, is what this actually looks like in our tools, where you actually have the ability to build groups in an input configuration, group things together, and then make these custom exports either available in real time, re-renders available either in real time or in offline. Okay. Given the amount of time that we have, that there's 2 basic products that we have. The Dolby Atmos renderer is a single piece of software. However, it is sold in 2 different license configurations. There's the mastering suite, for using an external renderer in one of 3 configurations: a PC that uses MADI, or a PC that uses Dante I/O, or a Mac that uses Dante I/O, and your DAW would connect to these. We also have the same software that's licensed for use in this, on the same CPU as your DAW, and it is used for mastering, but also mostly for sound, ideally for sound design, offline re-renders, for QC of your master files. And there's 2 basic ways to get in and out of that renderer, using either a send and return architecture or the Dolby Audio Bridge, which is a core audio emulation. There are some limitations to using the production suite over the mastering suite. Some features that it doesn't have, but the main issue is it's just overhead that drives on one CPU. Again, for using the send and returns or the Atmos product or the audio bridge, there are pros and cons to both. The main one, pro of using the send and returns is that you get to use the DSP processing on your HDX cards if you're using Avid Pro Tools. The big downside, if you're using Pro Tools with the send and return plugins, is there's no automatic delay compensation. The busing is complicated, and moving back and forth between the 2 renders is pretty tough. The audio bridge gives you 130 tracks, which is all fine and good. If you're using Avid HDX cards, at that point they just become audio interfaces, and you don't get to take advantage of the DSP that's on there for plugins. You do, however, get 130 tracks, and you get the automatic delay compensation for plugins. So those are the 2 basic platforms that we have. Hardware-wise, you can talk to your dealers about what's required. If you're talking about Pro Tools and you want the full whack, you're talking about a dual HDX system, or a native or single HDX system. There are other things that are nice to have for sure. They're not necessarily required. Note the word recommended and optional are used in this slide. If you're comfortable mixing in the box with a mouse, you don't need a control surface. If you'd rather have a control surface, there are various ones available that you can use. Obviously, it starts upping your general cost to go that way. 714 monitor control systems are really a very nice way to get going. To get started, you could put up overhead speakers, calibrate them to reference level, use a 7.1 controller, get it to match, and you use the attenuation in the software, to adjust levels thereafter. There are a lot of ways to start working in Dolby Atmos that don't require necessarily throwing out the baby with the bathwater and getting all new gear, from the get-go. Your dealer, of course, would be perfectly happy if you did so, but it shouldn't be looked at as that massive of a barrier to get started working in Dolby Atmos. And that's what it looks like on a nice S6 with the native panning automation integrated there. All right, so let me, without further ado, and I just wanted to show that I have been talking about Pro Tools at this point. There are other DAWs that can be used with Dolby Atmos Production Suite and the Dolby Atmos Mastering Suite. Nuendo is certainly one for using Dolby Atmos music. There's Logic and Ableton. Blackmagic Design Resolve with Fairlight is also an emerging player as well. So let me quick jump into looking at the renderer itself and give you a quick discussion of what some of these things are about in just a few minutes that we have before we start taking questions. So this is the basic interface for the renderer. If you haven't seen this, this is showing you your 128 inputs that we have here. Again, the first 10 are dedicated to being bed inputs. That's why they have a purple block around them. I have set up my speakers to be a in my room setup to have a 714 reference listening configuration. This can go up to 21 18.6 by 1. You can use arrays with the mastering suite license. You can use custom down mixes and monitor down mixes as well. Speaking of those down mixes, when you do want to create 5.1 down mix information that the encoder is going to use, this is where you're telling the encoder what down mix mode it is going to use, whether it's going to, take those 16 spatially coded clusters and render to 7.1 and then down mix to 5.1, which are what these two options would be, or whether it's going to render directly to 5.1. And there's two different modes for doing that. That either sort of direct render with warp is probably the most useful because it keeps things from going too far forward in the room by creating phantom side surrounds. These are written again into the master file. They can be used for your re-renders, or you could be using different modes with these. There are trims that you can use for how the heights, any overhead content folds down into the 5.1. I would strongly suggest you start leaving things in automatic. Automatic is automatic for a reason. It works very well. It is not just a single down mix coefficient for how things are folded down from the top. It is dynamic depending on how far on the z-axis things are, and it works really well. The other thing that's quite important that I wanted to illustrate is in an input configuration. By default, again, it's 10 group. For the first 10 inputs are for channels, and everything else is set up for objects. When you start talking about a multi-bed workflow, as I was discussing, you could have a re-render configuration that would create multiple beds on your input, as you can see here, and this would start assigning different inputs to two different groups, let you use scribble strips that show up back into your DAW, and in conjunction with using templates in your DAW, you have a very repeatable and useful way to work in a multi-bed workflow with multiple premix stations going forward. So let me, real quick, I just wanted to bring up a couple of other concerns that if you're working in post that you should know. Multi-beds do facilitate a lot of things. Dialogue beds should be as wide as the reverb returns that are going to be used on them. I mean, granted, your dialogue's usually in the front, but if you're going to be putting reverbs on them, you might want those to 7.1.2. The scribble strips I just showed you are totally helpful. If you're delivering a multi-bed ADM to somebody, deliver the Atmos IR file like I just showed you, so that configuration can be used along with it. Be aware that the loudness measurement in our render is based on 5.1, and this preserves loudness consistency. If you're using Pro Tools to achieve loudness targets while you're mixing, use master VCAs, because that is the best way to attenuate and add gain as needed. If you were using external loudness measurement, use the re-render type that has the limiting applied that matches what our encoder does. True peak levels, there's lots of delivery specs that call out true peak levels for 5.1 content, etc. For Atmos work, the idea is you really just need to aim at a true peak level. As long as it doesn't clip and exceed it, it's going to hit the limiter in the encoder in the first place. So that don't, go for a target, but don't really worry about where that winds up as long as it doesn't clip, because it will be attended to in the encoding process. If you do have to achieve peak limiting requirements for the 5.1 or 7.1 or stereo deliverables, know that you'll need to do that in your back in your DAW to make sure that you get those sorted out. If you're using Pro Tools, start with stereo outputs to feed the renderer. You can always make mono sub pads, and having the same as working in 5.1, having stereo outputs set up means that you can use existing stereo effects, sound effects that you may have, or music elements, and use them in an immersive sound field, which is really quite compelling to pull stuff off of the screen. I showed you those 4 down mix modes. I would suggest starting with some of the defaults of, the 7.1 to 5.1 or the direct render with warp mode. There's a lot of flexibility built into our renderer in terms of how you can down mix things and do things with trims. Again, you could spend forever listening to these things, but just be aware that you're monitoring how your mix is going to sound in 5.1. Make sure that you're happy with it, but just if you're just starting out with this, I would use the defaults and not go down a rabbit hole right away. If you're going to use the decisions of using multiple beds or when to use beds and objects is a creative decision. In some of the previous webinars that you've already listened to, some mixers use beds pretty much exclusively and just use some additional objects to embellish and where they need that granularity for panning. Other people do everything in objects. It is entirely a creative decision. And as with working in 5.1 or anything, track management, is obviously is an important concept, and using templates can be super helpful in terms of getting your workflow done. At this point, let's quick open for questions here. Tom?
Yeah, thanks, Adam. That was great. So let's first talk a little bit more about spatial coding. I think there's a concern that mixers are afraid spatial coding will be applied after they've already sent the mix out the door. Specifically, the Netflix delivery specs for HE were asking for the 7.1.2 bed and said tracks 11 through 128 may be used for objects or beds, delivered with the Dolby Atmos ADM B-Wave file. There was no mention about spatial coding or these different codecs. Is this a new workflow? So I think talk about the renderer, the fact that you're emulating spatial coding while you're mixing won't come as a surprise after you ship.
Yeah, so it's not a workflow. Spatial coding and the codecs have always been part of it. This is how Netflix delivers content to end consumers. But as Tom said, it's a reason why you need to listen to your content and make sure you're happy with that mix that you are delivering as the ADM B-Wave, that you're happy with how that sounds with spatial coding emulation turned on, because the spatial coding process will be employed during the encoding process. That is how Netflix delivers that content. That's why you
is emulating that spatial coding already while you're mixing.
Yep.
Yep. Cool. Another question along a similar line about spatial coding. Let's say you've been recording acoustic music in 7.1.4 with 12 discrete channels. You're done with the mix. It all sounds good. You're now asked to deliver an Atmos version. Can you reliably create 4 static objects positioned in the 4 top corners of the room to preserve those original 4 top channels? And can you be sure they won't be quote unquote clustered?
Yeah, you absolutely can do that. So, I mean, in that case, you would use the first 7 inputs of the renderer would be a 7.1 bed, and then you would have 4 object tracks from 11, 12, 13, and 14 that would be hard pan to the to the 4 top corners, left top front, left top left top front and rear, right top front and rear. It will go, and you can master a Dolby Atmos master at that point. It will go through the spatial coding process in the encoder. However, there is not going to be anything for spatial coding to do. Spatial coding is going to be looking to how is it going to get more things, up to 128 down to 16. If there's only 12 things there and they're not moving, spatial coding is going to be used, but it's completely transparent at that point. Basically, each each one of those discrete inputs is going to have its own element or cluster with static OAMD at that point. So that shouldn't be a concern at all.
Yep, thanks. So a codec question, will AC4 replace DD plus JOC, Dolby Digital Plus Joint Object Coding? Is it possible to do the same Dolby Atmos metadata in EAC3 JOC as well as AC4? I love these softballs, by the way.
AC4 and DD plus JOC will coexist for quite a while. They're kind of, AC4 will certainly encroach, on DD plus JOC, but I don't think DD plus JOC is going to go away entirely for quite some time because they're used for different things. AC4 IMS uses the binaural metadata in its encoding, as opposed to a spatial coding process and then hitting the OAR. So they are different encoding processes. It is wise to listen to your mix, and I'm glad this got brought up, and I'm sorry I didn't have time to show the binaural metadata panel. It is important to listen to a binaural headphone mix of your content, as well as listening to things with spatial coding, in case this content ever does wind up encoded as Dolby AC4 IMS to be listened to either backwards compatible with stereo or in virtualized Atmos, because they are different technologies that yield very comparable results, but there are differences in terms of what those codecs are trying to achieve in terms of bit rates for delivery and target devices.
And by the way, Carrie Thomas in our Dolby Atmos music webinar series has an entire webinar just about binaural. So that's a great thing to check out if you're interested.
Cool, thanks, Tom.
Sure. Adam, let's talk about the export to MP4 feature. Someone is asking, can we see how to quickly create an MP4 video with integrated Atmos for QC? And another person had a similar question about how can I QC Atmos on my soundbar? So,
okay.
Answer.
All right. Hang on. All right. So you guys, are you seeing my screen? Are you seeing the renderer there?
Yep. Carry on.
Okay. So export audio. Let me quick load up a master file. Okay. So when you export out to MP4, it is encoding Dolby Digital Plus JOC and muxing it with black video to create a standalone MP4 file that has Dolby Digital Plus JOC as a .ec3 file multiplexed with 4 frames of black H.264 video. You can take this MP4 file and put it onto a USB drive to jack into a Blu-ray player that is set for bitstream output and connect it to a soundbar, and you will hear your Dolby Atmos mix reproduced as DD plus JOC through your soundbar. If you have a Mac and you have and an Apple TV and you have the Plex, you would install an application called Plex Server on your Mac and the Plex app for your Apple TV 4K, and you could then share a folder and play from your Mac that MP4 file through the Plex app on the Apple TV 4K connected to your soundbar as well. There are other ways to then demux this MP4, add your own video to it, and package it for streaming so that you could use AirPlay to an Apple TV 4K. You could use VLC and send it to a Chromecast device connected to your TV. I have some knowledge articles. Good segue here. Some knowledge articles that are on our.
Why don't you go ahead and look for it? And you may have already said this, and I was skimming ahead for future questions, but the simplest use case is taking that thumb drive and plugging it into many brands of UHD Blu-ray players or standard Blu-ray players, or even right into some higher-end televisions. And either the TV or the Blu-ray player can directly play that media and stream the Atmos bit stream to your decoding device, whether it's a sound bar or an AV receiver, just to make sure that bit stream output is selected rather than internal decode.
All right. So, hey, this is developer.dolby.com. If you go to developer.dolby.com and get down to our support knowledge base, you'll see knowledge articles on the production suite and the mastering suite. And I have a few articles here on how I can put my own video into the MP4 file instead of black, how to, using Dolby's public tools to do this, how to use Amazon Web Services Media Convert to create streaming content that you can use to playback on consumer devices, and you could also use to host this content and to send links to people so that they could possibly do remote mix approvals on their consumer content with using the MP4 from the renderer as a source. But also, please do take advantage of our knowledge base in forums going forward, because there's some good information up there.
We're giving you all homework. Okay, so let's clear up the difference between beds and then the minimum Atmos room configuration, which is 7.1.4. So Dolby Atmos beds are 7.1 with stereo overheads, so left overhead total, right overhead total. But the room config is 7.1.4, where you actually have 4 overheads. So the specific question is, what's the best way to set up a 7.1.4 control system? In a standard 7.1.2 Atmos setup, the surround bed uses outputs 1 through 10 with the objects starting at 11 through 128. With a 7.1.4 setup, is the bed 1 through 12, and do the objects start at 13 through 128? I want to make sure I route the bed and objects correctly.
No, so the outputs used for a monitoring configuration are a separate deal to what is the input configuration to the rendering tool. On the input side, to the rendering, to our renderer, the first 10 are set up for a 7.1.2 bed, and thereafter you'd have objects. If you're going to set up a 7.1.4 speaker configuration in the renderer, you can choose what order you want those things to go in the renderer itself, but generally speaking, it's going to be the 7.1 will be the floor channels, and then 9, 10, 11, 12 will be the left top front, right top front, left top rear, right top rear. So that you need to divorce those two concepts. So in the routing, this is the default way it's set up, is 1 left, 2 right, 3 center, the rear surrounds being 7 and 8, and then the overheads being 9, 10, and 11 and 12. So, and you can change this either here, or you could change it in your monitoring control. But again, 7.1.4 monitoring config as opposed to 7.1.2 bed inputs to the renderer are a different deal. When you play back a 7.1.2 bed in a 7.1.4 speaker listening configuration, that left top and right top will come out of the front and rear, because there will be no dedicated middle. If you set up a if you had a 9.1.6 environment, the +2 from the native 7.1.2 bed in Pro Tools would be reproduced in these two, in the LTM and the RTM. With 7.1.4, the +2 from the Pro Tools 7.1.2 bed go to the left and top fronts, the left and rears, but you don't have the granularity of front and back panning. Hopefully that answers that question, because I know we're pretty much out of time.
Quick one, is the Dolby Atmos production suite, as opposed to the mastering suite, capable of decoding an already encoded mix? And if so, does it work in conjunction with the RMU to do that? So maybe we talk about production suite in use for QC for masters, as opposed to QCing Dolby Digital Plus encodes, for example.
No, so our content creation tools can only play back masters. So they can play back a .atmos file, an ADM B-Wave, or an IAB MXF. Those are the only kind of files that you can load into our our content creation tools, whether the Dolby Atmos renderer, whether as the mastering suite or the production suite, and hit play, and or have it chase time code from your DAW. So you can't QC encoded content with our content creation tools. You have to use dedicated tools like either playing them back on consumer devices, or there will soon be a replacement for our Dolby Media Decoder component that will work in Catalina that will be out soon. But those are usually associated with the encoding tools themselves.
Just skimming down. Good, thank you. No, I'm skimming down for additional questions, although I think we are just about out of time, which is a shame because we still have a lot of them. But you know what, as I said at the top, this might be a good opportunity to say, you know what, maybe we just need to do an all Q&A future webinar event.
I would be happy to do so. So hang on to some of those questions.
Yep. And so let me put this back up, our PowerPoint slide. So Adam, thanks so much for covering all that. This was great.
I know it was a lot to run through, so I apologize for the frenetic pace, people.
Doing deeper into the stuff that I barely skimmed over in the why and how presentation. But once again, here are the QR codes for the Dolby Atmos Production Suite free demo license, which you can use if you don't already have a compatible DAW. You can use in conjunction with the free demo that Avid is offering with Pro Tools Ultimate. Some good demo content to actually play with and get your feet wet with mixing Dolby Atmos is courtesy of Netflix and their Sol Levante anime piece. Our webinar series, our previous webinars, as well as this one, which will be posted there in a few days, is available in that third QR code website. And then all of our other webinars about Dolby Vision and Dolby Atmos music creation and podcasts from the Dolby Institute are all available on professional.dolby.com. And by the way, Tom Graham, the other Tom on my team, is going to be doing a Dolby Vision webinar today at 11 a.m. Pacific. And his guests are going to be the founders of Mystery Box, which is a travelogue and documentary videography company, and they work extensively in Dolby Vision to create some really beautiful, compelling content there. So that webinar is coming up in less than an hour from now. So that is our presentation. Everyone, thank you all so much for joining us. We had a great turnout, great questions, and Adam, again, thank you.
You're very welcome. Thanks everyone for listening.
Have a great day.